All right, CUA1 retake. I will do the odds, you will do the evens. Number one, we're going to solve this equation. So we're going to start by taking away the 2 from both sides. That's going to get 5t by itself, and we're just going to bring down everything else. 12 minus 2 is 10. Then we're going to divide both sides by 5. That will undo the 5 times t, leaving us with just t, and 10 divided by 5 is 2. Pro tip, always check your work by plugging in your final solution. So we're going to do 5 times 2 plus 2 equals 12. We're going to just check to make sure that's correct. So if we use PEMDAS here, we'll see that yes, we get 12. So that's good. Try number 2. Number 3, complete the proof. Given this equation, we need to prove that x equals 6. So here we have a list of statements, and we need to give the reason for each one. First statement in a proof is always your given information or your given statement. All right, now let's see what's happening to get from this first step to the second step. Looks like we're subtracting 15 from both sides, and so that would be the subtraction property of equality. And then to get from the second to the third step, it looks like we're dividing both sides by 4. That'll leave us with x equals 6, and so that was the division property. All right, just to try to make it a little bit more clear here, whatever you do to get from this step to this step, that's what you write here. Again, whatever you do to get from this step to this step, that's what you're going to write here. I know it seems odd, and you're thinking, oh, I'm going to put this here, but no, that is not the case, because this is how we got this. This is how we got this. Okay? So be real careful with where you put the reasons. Try number 4. All right, number 5 through 9, name the property that justifies each statement. Number 5 says if x equals y, then y equals x. That is the symmetric property of equality. If you forgot the properties, then you need to check your notes. Go ahead and do number 6. Number 7, if x plus y equals y plus z, use the indicated property to complete each statement. Actually, you go ahead and try number 10. Okay, number 11, symmetric property. If the measure of angle MNO equals the measure of angle PQR, now if we use the symmetric property, you just flip them. So the measure of angle PQR also equals the measure of angle MNO. Try number 12. Number 13, we're going to use the division property to complete the statement. So if 2 times the length of FG equals the length of ZY, then we can assume that FG, or 1 length of FG, would be half of ZY. So let me kind of explain why a little bit. If we divide by 2, that will eliminate the 2 there. Not eliminate, that will cancel out, sorry, the 2, and that will leave us with FG. So as you can see on the other side of the equation, now we're just left with half of ZY. So you can write it as ZY divided by 2, or you can write it as 1/2 ZY. Try number 14. All right, number 15. Let's see if we can figure out which one this is. All right, here we go. So a line has 1 dimension and extends indefinitely in opposite directions. Try number 16. Number 17, collinear points. So the points that lie on the same line. Go ahead and try number 18. Number 19, a line segment is a part of a line with two endpoints, excuse me, what to say. And you try number 20. Number 21, opposite rays, two rays that lie on the same line and they have one common endpoint. Try number 22. All right, number 23, to find the slope. Don't forget we're going to do y2 minus y1 divided by or over x2 minus x1. If you want to label, go ahead and do that. That helps. It can help. So that means y2 is 3, y1 is -4. Notice that we're supposed to have a subtraction sign between the numbers. So I put it right there. 4 is negative, so make sure you include both of those. The bottom, x2 is 7, x1 is also 7. So since we have a double negative happening here, that's going to be plus positive. So 3 plus 4 is 7, and 7 minus 7 is 0. We cannot have a 0 in the denominator. That means this slope is undefined, which means that this is a vertical line if we were to graph it. Try number 24. Number 25, write the correct notation for line segment RT. Boom. Go ahead and try number 26. 27, name the intersection of plane L and plane K. So plane L is this guy. So this is plane L. All right, so that's plane L. And then we need that the K, plane K. Sorry. Let's use a darker color here. Okay, so this is plane K here. Well, wasn't that dark? Oops. All right, so as you can see, these two planes, if they could go through each other, they would go through each other right here. And that is line MN, or you can call it GN or GM. Doesn't really matter. I'm going to call it MN because I feel like it. All right, number 28, give it a shot. Number 29, give another name for plane L. So again, we're looking at plane L here. And we can use 3 non-collinear points to name a plane. So I'm just picking those 3 points because they're not on the same line. So this is going to be plane D, G, N. And you could do, just pick 3 points that are not on the same line, then that will name the plane. Try number 30. Sorry. Try number 30. Number 31, what are the 3 undefined terms in Euclidean geometry? That would be point, line, and plane. What is the name of a ray that goes through? Sorry, try number 32. Number 33, what's the correct notation for line PQ? There you go. Go ahead and try number 34. Number 35, write the equation of the line through the 2 given points in the slope-intercept form. In slope-intercept form, excuse me. So, first thing we need to do is find the slope. So that would be M equals, and we're going to do x1, y1, x2, y2. All right, so we're going to have y2 minus y1 over x2 minus x1. Got a double negative here. All right, 9 minus 15 is -6. 1 plus 2 is 3. We simplify that, we get -2. So now that we have the slope, we can use one of the points and plug it into point slope form, which is right here. Are there other ways to do this? Of course. If you can figure out the other way, go forth and be great. All right, so y1 was 15. The slope was -2. x1 is -2. Okay, just to be clear, this is x1, this is x1. This was y1, this was y1. And then the slope was -2, and that's where we got that from. All right, so let's clean this up. We have a double negative here. So that's going to be y minus 15 equals, let's go ahead and distribute this -2. Boop. -2 times x is -2x. Boop. -2 times +2, because remember we changed that to plus +2, will give us a -4. Last step, we're just going to add this 15, so it'll zero out. And that'll give us y equals -2x plus 11. And there you go. Go ahead and try number 36. All right, number 37. To determine if something's parallel, two lines or slopes are parallel, perpendicular, and either, what you're going to have to do is, well, this one's pretty easy. We already got the slope. For number 36, you're going to have to figure out the slope for both of these. And then once you figure that out, you do what we're going to do here. So I see that these are in, one's a decimal, one's a fraction. Let's change them both to fraction form. So we got -5/2, and I just showed you how you can change it as well. So -5/2. Oh, snap. That's the same number. All right, equal slopes mean parallel. If you can't remember, look at your notes. Go ahead and try number 38. Number 39, write the equation of a line perpendicular to line AB that passes through point P. All right, so the coordinates for point P are -1, 0. And the equation of line AB, sorry, the slope of line AB, excuse me, appears to be -1/4. Okay, because we went down 1 and to the right 4. So down means negative, right means positive. So that's how I got -1/4. So now we're going to use point slope form. So this is going to be y minus y1, and this is our y1, this is our x1. So that's y minus 0 equals the slope times x minus -1, which was our x1. And then we're just going to tidy up. We're going to simplify. Y minus 0 is just y. And we have a double negative over here, so let's take care of that. And now we're just going to distribute. -1/4 times x is -1/4 x. -1/4 times 1. Hold up. Yep, messed up. Okay, hold on. Get rid of that real quick. All right, so this question does not say parallel, it says perpendicular. I cannot use the same slope. I need to use the perpendicular slope, which means I need to flip it and change the sign from negative to positive. So 4 should be my slope. My bad. All right, so we're going to continue. Y minus 0, still 0. 4 times x is 4x. And we still have a double negative here. So we'll just go ahead and distribute that. 4 times +1 is just +4. And that would be our equation. Now, being the paranoid person I am, I'm going to graph it to make sure that it's correct. So we've got y equals 4x plus 4. So this is our y-intercept. So 1, 2, 3, 4. Boom. This is our slope. So I'm going to count the slope from here. So we got to go up 4, right 1. Well, I can't do that. I'm out of space. So I got to go opposite. Down 4, left 1. Okay, there you go. So these are looking pretty perpendicular to me. All right, chart number 40. Number 41, right? The equation in slope-intercept form of a line that goes through this point and it's perpendicular to this line. All right, so first let's find the slope of the line. If you want to, you can use the standard form slope finder because this equation is clearly in standard form. So that's going to give us negative 3 because that would be our A, that would be our B. It's a 1 over 1, and so that's going to give us positive 3 for the slope. However, we don't want the parallel slope. Don't want to make that same mistake twice. So we need the perpendicular slope, which would be negative 1/3. Flip it, change the sign. Now we can use point slope form. And we're just going to plug in these two numbers. This will be our x1, this will be our y1. So we got y minus 5 equals, what was m? Negative 1/3 times x minus negative 3. Once more, this is my x1, boom. This is my y1, there we go. And this is my slope. That's where I got those from. So now we're going to clean this up. We got a double negative we need to take care of as well. So I'm going to start by adding, oh, can't do that first, that was silly. We can't add that first until we distribute the 1/3, the negative 1/3. All right, so negative 1/3 times x is just negative 1/3 x. Negative 1/3 times positive 3 is going to give us a negative 1. And now we can add the 5 to both sides. My bad, I was jumping the gun. So that's going to be y now, because it's zeroed out, equals negative 1/3 x, and negative 1 plus 5 is simply positive 4. All right, for number 42, I'll get you started, but you're going to have to finish the rest. So here we're going to put E for Euclidean geometry, and then over here we're going to put M, which was spherical geometry. So I'll write it. Okay, and you're going to put all of these where they go in the Venn diagram.